to Solving for the Undefined podcast. I'm your host, Johanna, founder of Miss Kuiper's Classroom, the place that equips teachers in creating a healthy math classroom where students can thrive, no matter their academic abilities. But it's not always about the numbers, and that's why I'm here, bringing you the formulas to solve your problems, math and otherwise, plus strategies on cultivating that necessary math mindset. And that's what you can count on. Hello, and welcome to a brand new episode. Because today is the first episode of the month, that means today is a breaking down a math concept episode, where I show you how I would scaffold a concept for students struggling with on-grade level math. And today's episode, I'm going to transform your thinking. I'm going to take this math concept, translate it into student-friendly learning, help us teachers reflect on how to best support students with this concept so we can rotate in a happy dance as students dilate their knowledge. Have you figured out what today's concept is? Geometric transformations. Translate, reflect, dilate, rotate, etc. Yes, I did go the nerdy route. However, I would like to inform you I don't regret it at all. But moving on. I just finished up teaching the basics of geometric transformations with my students. It's the first time we've ever done it at the beginning of the school year, just because our new curriculum does it that way. But now we're moving into the sequences of them, meaning that we do more than one transformation on the same graph. The reason I share this is that lets you know that some of my scaffolds are fresh from the classroom, and I have to say, this year, my students have shown the most growth out of other years that I've taught geometric transformations. So if you've been with me for a while, you know that I teach at a Title I school. This means that the majority, I'm talking like 75% of the families, I think, at my school are living at or below the poverty line. What this means for education is that these students have outside factors that can affect academic, cognitive performance in school, as well as there's some emotional engagement and in-school behavior. And because of this, in my classroom, I need to have a great deal of flexibility to provide differentiated and scaffolded instruction that works best for my students. I have to find a way to approach math in such a way that builds a bridge from whatever they last learned and retained in math to whatever we're working as an on-grade level subject. I do my best throughout the school year to supplement and support that bridge with missed learning or gaps of learning, but there's only so much I can do in 1 year with each of my 110 students. And granted, this year is definitely very different because we've had 2 years of online/hybrid learning, and so there's a lot more gaps than there might normally be for working with students at the 8th grade level. And that by no means is any one particular's fault. But I do have to figure out a way in my classroom to be able to teach the 8th grade math concepts while supporting whatever gaps those students have. That's why those bridges or scaffolds are vital in math. So today I'm going to share how I build those bridges with geometric transformations. I'm going to be using Common Core State Standard 8G3, which states, describe the effect of dilations, translations, rotations, and reflections on a two-dimensional figure using coordinates. That's my goal for students. Everything we do in class is based on students being able to master that standard. So first, I want to start with students learning what each of the 4 transformations are. What does it mean to translate? What does it mean to reflect, rotate, and dilate? This is newer for me this year, having students start off with this idea rather than just jumping into these are what they are and moving on to translations. But I really liked how we started having students be able to identify on a coordinate plane which transformation is happening. So what I do is in their notebook, we turn it sideways, create like a 4-pronged T-chart with each one of those sections labeled with a different transformation. Translation, reflection, rotation, dilation. Underneath, to help the students, we identified a shorthand that guides them to the academic vocab. So for translation, we said slide. For reflection, we said flip. For rotation, we said turn. For dilation, I had no idea what to come up with, but one of my students said large and tiny. The reason why we use these specific words is for translation, it's slide. So in translation, the SL corresponds with the SL in slide. Same thing for reflection. The FL in reflection corresponds with the FL in flip. And that's why that student who came up with the one for dilation, large and tiny, dilation has the LAT. So it just gives a little bit of visual as well within the academic word to whatever our slang term is. Because the goal is for students to be able to still identify with the academic vocab, but the slang is a good starting point to bridge their normal everyday understanding of words to our math academic vocab. So inside of that 4-pronged T-chart, after we've done our slang version of the word, I give the students 4 graphs, which is a lot of cutting on my part, but I think it's effective. So a transformation has happened on each of the 4 graphs that I've given them. They're now going to sort them into the correct spot based on what they see on the graph. So if they see that one maybe is sliding across the graph, they'd put it in translation. Or maybe this one is a flip, and so therefore it'd be a reflection. And so it gives a chance for students to give a picture association with the slang word and therefore the academic word without any real guidance from me. I usually have them do it with a partner because it's brand new and more minds are better than one. It's usually a pretty quick 2-minute, if that, activity, but it gets the word associated with the depiction of the transformation. And then after we do that and we kind of go over it as a class, make sure that we understand which graph goes with which transformation. One of my favorite things is to have them come up with some examples of each of the transformations from something outside the classroom. For example, like with translations, a conveyor belt, a car driving forward. For a reflection, a mirror or looking into a pond and seeing your reflection. Rotations, a clock, tires on a car, the earth rotating around the sun. And for dilations, your pupils or water beads, etc. Connecting math to things outside the subject gives them relevance, purpose, and it helps provide those connections for students who have those gaps in their learning. It helps bridge what students know in their life to the math itself. And then after we do this, we just provide some additional practice to solidify the math aspect, like a card sort, whether it's print or digital, task cards, mazes, whiteboards. Ooh, I love whiteboards. So what I did with this is I printed out a bunch of different graphs with different transformations on it. And then we do this thing called Show Me Your Math. I think I did it more last year than this year, but it's a lot of fun. So what I would do is I took a task card that had a graph on it with a transformation. I put it under my document camera, and students on their whiteboard would write which transformation it was. And then when I say, show me your math, very Tony the Tiger Frosted Flakes, they would put up their whiteboards to show me what transformation they saw it was. And there are some of them, especially with reflections or rotations, depending on the shape, where it could be either of them. And then we have to have a conversation about, all right, now we need to look at our vertices, the corners of our shape. See how this one says ABC, but when it's flipped over, it says ACB. Now we could tell that that's a reflection, not a rotation. And then it leads us into more conversations about some of the other key pieces of it, like prime, pre-image versus image, vertices, corresponding sides and angles, etc. So that's also another day that we add into that, but it gives great discussion time. And then once this is complete, it's time to move into each individual transformation. And I guess with this, I should also say, this is not something I do in one day. I'm going to make it seem maybe that it's in one day, but we do this over many weeks. So I think our transformation unit has been 7 or 8 weeks so far. So it's not just 1 week or 1 day that we're doing all of this in. All right, jumping into translations. For me, translations always seems like an easier one to start with because it just slides around on the graph. It maintains its orientation. So I like to start with translations with a single point doing one movement on a one quadrant graph. I think this really helps students be able to count the number of spaces and get used to the mechanics of translations. I have those clear dry erase sleeves that you can put stuff in and students can draw over them with dry erase markers. But I put a one quadrant graph in those sleeves and with a single point in the middle of the graph. So it's like a 20 by 20 graph with a single dot in the center. And then we just practice. I say, move the dot 3 to the left. All right, let's start over. Move the dot 4 down. They very quickly get the hang of moving the dot around the graph. So then we up the challenge. We practice doing 2 movements, always starting with the left or right movement first, because when we get to the algebraic rule, the x value always goes first. So saying like move 2 right and 4 up. And again, students get the hang of this fairly quickly. We're moving the dot 2 different directions on the graph. But now we need to look directly at the coordinates because the standard says we need to describe the effect using the coordinates. So we go back to one movement. If I move it 3 to the left, what do you notice about the coordinates? So we take it for the pre-image, we take it to the image. What do you notice? Turn and talk with a partner. And then you can usually see that, oh, we moved it this direction, and so the x value is changing in our coordinates. And we just take a note of that. And then we do it for all 4 of directions. What do you notice? And students end up being able to find that if I move it left or right, the x value changes. If I move it up or down, the y value changes. And then based on our findings, we take note of it in our interactive notebook. That way they can go back to it if they need to. And then from there, we practice creating the algebraic rule. So we looked at the coordinates, we noticed what happened from one to the other. So let's work with move to the right and 4 up. Now we looked at those coordinates, the x value added 2. So then we create a rule that says x plus 2. And then looking at the y value, oh hey, it moved 4. We added 4. So in that coordinate, we'd write y plus 4. And then putting it together, we have xy becomes x plus 2, y plus 4. And that would be our algebraic rule. And then from there, we just practice that. With 2 different points, what do you think the algebraic rule is? I have a set of task cards that I use specifically for this. So on the task card, it has a graph with 2 different points on it. And so then they write down the coordinate points and then create the algebraic rule based on what they see. And yes, they could just count on the graph as well, not having to write those coordinate points, but it still gets them that practice of creating the algebraic rule from looking at a graph with the translation. I also have the task cards in a Google Sheets version, meaning that it can be self-checking for students, which is another great scaffold for students who need that immediate feedback. So you can find both of those in the show notes on my blog, and it'll take you to my TPT store. Or if you buy it directly from my website, it is a little bit cheaper for you. Just as a little bonus for you. And in addition to having them practice creating the algebraic rule from 2 points, I have them practice giving directions based on a rule. So I have a little fun activity that I do collaboratively with this one. I have a I have who has activity where I have is the written movement. So move to right 4 up. And while the who has is the algebraic rule. So the way this works is we stand in a circle around the classroom. If you've never played I have who has before, so on the cards, you have the I have. It's kind of like a scavenger hunt almost, where you have the answer up top and the question on the bottom. So say I have move to right and 4 up on the top. So whoever says x plus 2, y plus 4, they'd say, who has x plus 2, y plus 4? And I'd be like, oh, that's me. I have moved to right and 4 up. And then I would read my who has. Who has x minus 2, y plus 3? And then whoever has, I already forgot what I said. Was it move to left and 3 up? Would then go next. So it's kind of like a scavenger hunt on a whole class scale. It's a lot of fun and students typically enjoy it. From there, we add shapes into our translation so that way students get the practice of moving the whole shape over. And the one thing that I notice with this, a lot of students, is they'll count from the end of the shape to the beginning of the new one and not from each individual point. So what I like to do is have them write out the coordinate points for each of them. So if it was a triangle ABC, they'd write out the coordinates for A, B, and C of the preimage, translate it how they think it would go, and write down the coordinates again. And the next problem is check to make sure that your algebraic rule matches up for your coordinates. So giving them a chance to self-check and self-regulate their answer. But it also helps if you as the teacher model counting from each individual each individual point rather than the end of the shape to the beginning of the new one. Just one thing I notice a lot with students. And then as some final practice for translations on a coordinate plane, I have this fun activity where, again, it's with the dry erase sleeves, but I guess you could laminate them too if you don't have them. But it's a graph that has a shape on it, and then it has a blank space for the algebraic rule. Now students would roll dice to fill those blanks. So it says xy becomes x plus blank, y plus blank, and students would roll dice for them. And then whatever it is, the students would translate it on the graph. It's just another fun way to practice that's a little bit more interactive than a worksheet. And then after we've practiced it, it's time for an assessment or a celebration of learning, as I like to call it, because whatever you've learned is worth celebrating. I go into details about that on my blog this week, so if you're curious about that, feel free to check out my blog post that comes out on Wednesday. All right, so we give the assessment, we talk about it as a class, and then we move on to reflections. And remember, reflections is a flip because that FL on reflections leads us to flip. Whenever I'm doing reflections, I always start with a triangle. Just the idea of something pointing a different direction, I think really helps solidify the whole, oh, it's flipping it. So keep that in mind as I talk about some things that I use. So first thing I always do is we practice identifying if a reflection happened over the X or Y axis. So I usually do this by giving this little weird analogy. So if I'm reflecting over the x-axis, I'm taking a bow. So it's like folding it over the x-axis. So I'm bowing down. But if I'm reflecting over the y-axis, it's giving it a high five. Kind of like if I were to reflect my body in half or fold my body in half and I would high five myself. It's like over the y-axis. Maybe that doesn't translate through audio, but that's the analogy that I give my students. This is another great opportunity to bring back the show me your math, where I put a reflection underneath the document camera, and then they would write on their whiteboards whether it was over the X or Y axis. Oh, I just thought of another way that I help students with X and Y axis. It's not necessarily for reflections, but it's kind of cool. So for X axis, to help students remember it's the horizontal one, if you've seen New Girl, there's an episode where Jess is giving a presentation to her coworkers at her school, and she says, shut it down, and does like the X in front of her hands, and then when she says shut it down, she like flares them out, but you do it horizontally, so it's like an X axis. So X axis, shut it down. So if you know that, you can visualize it a little bit better. And then for the Y axis, it's kind of like the YMCA. So you do the Y in the YMCA, and then you just like clap above your head. So you're creating that creating that vertical line. So Y axis. It's like the YMCA. That was a little bonus content for you right there. All right. So some ways that I help students with reflections is I use actual mirrors. I really lucked out on this one because for my wedding, my husband's family gave me some little tiny mirrors that you would put under like a votive or something, and so I get to use those in my classroom. And I got the idea from Grey's Anatomy. I know I'm making lots of references today, but in Grey's Anatomy, if you know the character Arizona, she loses her leg and she's having phantom leg pain, so pain in a leg that she no longer has. So the way that the doctor helps her is by placing a mirror that reflects the leg that she does have, and so her brain can picture it and make that connection. I don't know what medically it does, but it just helps somehow. But it reflects what's there. And so that's what I do with my students, is we hold up a mirror on our graph, either over our X or Y axis, depending on where we're reflecting it, to see what it would look like when we reflect it. So we put it on the line of reflection, we see what it would look like, and then we trace it on the other side. You can also do this with tracing paper. Tracing paper was a newfound thing this year. I don't know why I've never used it before. But it works with reflections as well as rotations. So for reflections, you would draw your line of reflection as well as the shape. Then you would flip the paper over and line up the two lines of reflection so they're on top of each other and look to see how it would be on your graph. Now I know with some like transfer paper you can like draw over it and it would actually draw it on there for you. I personally have not had success with that, so I just have students visualize what it would be and then draw it underneath. And then they can use that reflection transparency to see if their drawing on the graph lines up with what they have on the transfer paper. I hope this makes sense, because I can visualize it in my mind based on my experience, but if you haven't used it before, it might not make sense. I did, however, learn this from a YouTube video, so I will post the YouTube video in the show notes so that way you can visualize it as well. Alright, so we use the mirrors, we use the tracing paper, we use all of that, and now we need to look at our coordinates, because again, our goal is to be able to describe the effects using coordinates. So after we've learned to reflect either a point or a shape, I guess I should have mentioned this, I always start with a point first and then move into a shape, so that way students can get the hang of it. It builds a good foundation so students are stronger when it comes to reflecting a shape. So similar to the translations, we have a reflection and we want to see what the coordinates do. So we write down the coordinates for the pre-image and then for the image. What do you notice? And a lot of times, so if you reflect over the y-axis, your x value becomes the opposite. But a lot of students will say it becomes negative, which isn't necessarily wrong, but we wanted to attend to precision. So we want to make sure we say it becomes the opposite, because if it's negative, it's going to become positive. So we make sure that we do both directions so students can see what's happening. And then we do the same thing for an x-axis reflection. The y becomes the opposite. And we do it both directions, flipping up and then flipping down so students can see what happens to our coordinates. And then again, we take note in our interactive notebook so we have something to refer back to if we need it. And finally, to solidify our understanding of reflections, we practice using the rule to identify if it's going to be an x-axis or y-axis reflection. So I'll give the students a rule, an algebraic rule, and have them discuss what they think it's going to be, as well as giving them coordinates to discuss which one it's going to be. This fluency and understanding of reflections really helps solidify and help them retain the understanding longer than if we were just to practice a reflection over and over and over again. If you want to teach your students to reflect it over more than just the x and y axis, like the x equals y line or x equals 2, y equals 2, those kinds of things, those are not something I necessarily teach my students. It's usually an extension because I want to make sure they have the basic understanding first before applying new things. So if that's something you teach, I would still follow the same ideas, using the mirror, using the tracing paper, to really help students understand those things. And for that, it would just be making sure that you can see how far it is from one side of the line of reflection is how far it's going to be from the other side of the line of reflection. I love doing this with mirrors as well, because the further you get away from a mirror, the further it looks you are in the mirror itself. So that's a good way to kind of scaffold that understanding. And then, just like with translations, we give a small one-question celebration of learning, and then we move on to rotations. Our key word for rotations is turn. So it's all about turning an object around a graph. So the first thing we do is that we practice that when we turn, the direction we're facing is different. So I have all of my students stand and face me. And then we practice doing a quarter turn, which ends up being a 90-degree turn, and realizing that we're facing a different direction when we do it. So if we applied that to a triangle, and so I have my students take their hands and make a triangle in front of them, so that way the legs are facing out and then it's the point. And so we practice, if I were to move a quarter turn, 90 degrees, the direction my triangle is facing is not its original place. So when we're rotating a shape around the graph, it's gonna be a different direction. And with this transformation, the rotation, I think it's actually easier to start with a shape rather than a single dot. Because with that triangle, you can clearly see which direction it's facing or which direction it's pointing. So you can see how it's moving around the graph. Whereas a point is just a circle on a graph. And I have to say, rotations have always been a super challenging one for me to teach. However, I finally gave in to the whole tracing paper thing, and I can't believe I waited this long to use it. So, the tracing paper has been a glorious addition to my geometric transformations unit, both in reflections and rotations. So, if you haven't used tracing paper before for rotations, as a new convert, I offer you the invitation to start using it. Similarly with reflections, you take the tracing paper, you put it over the graph. I draw the X and Y axis as well as my shape. And then I have students take their pencil, break the center so it's holding down on their actual paper, and then rotate it 90 degrees until the axes are back where they should be. So then they can see, oh, it's moved a quarter turn, one box over, and now I get to redraw my shape, whatever direction it's now facing. And as you go through practicing rotating a shape around a graph, some students won't need the tracing paper anymore, which I'm sure if you've taught it before, you might know. But a lot of students can visualize it and visualize how it would turn and then redraw it in the new quadrant. One thing that I find extremely helpful when I'm teaching rotations is to also give them the understanding that how far it is from the X and Y axis when I rotate it is how far it's going to be from the Y axis and then the X axis. So when you're rotating it, the X and Y axis flip directions. So if it's 2 from the X axis, it's now going to be 2 from the Y axis. So giving them that spatial awareness as they're rotating it. And especially for students who are just visualizing it and not using that tracing paper, it's a very good piece of information for them to realize or be made aware of. So now that we've practiced rotations, rotating it 90 degrees clockwise, 90 degrees counterclockwise, we now give students the opportunity, and some of them have already noticed, that if I do it 90 degrees clockwise, that's the same as doing it 270 counterclockwise. And one of my favorite ways to do this is a warm-up. I just did it, and it's so fun to see students be like, oh, in my warm-ups, I usually give students 2 choices of what to do. So like the first choice was rotate the shape 90 degrees clockwise. And choice number 2 was to rotate it 270 counterclockwise. And usually students get to choose whichever one they want, and then they do it, and then they turn and talk to a neighbor and to see the different things. And so it was really fun to see, oh, yours is the same as mine. You chose something different than me. Huh. Oh, it means they end up in the same place. So it was a cool little discovery moment. Anyway, after practicing, we need to then move to describing the effect using coordinates. So we take our first shape, our pre-image, we write down our coordinates, we rotate it, we write down our coordinates. What do you notice? And this one's a little bit more effort because you have to do it for 90 degrees, 180, and 270. So it's 3 sets of them. And then they write down what they notice. And so this one's a little bit more challenging when creating the rule, or at least in my opinion it is. So we practiced looking at a rotation, creating the points, and then creating the algebraic rule. But again, similar to reflections, I want to make sure they have the fluency of doing it both ways. So I give them the algebraic rule as well as the set of the pre-image coordinates So what would the image coordinates be based on the algebraic rule? And then we do that for 90 degrees, 270, 180, as well as the counterclockwise. And I know they're the same, but to students, they may seem different. So I want to make sure that they have the understanding of all of them. And then to wrap things up, I have another dry erase sleeve insert where instead of rolling the dice for a number, it rolls it for a category. So students would roll for a category, say they rolled a 1. So 1 would correspond to rotate it 90 degrees clockwise. So on the transparency sleeve thing, they would rotate the shape 90 degrees clockwise. And I always do a front and back so that way if they get the same thing of 1, they can flip it over and do it on the back side. So that way they're not just stuck there doing the same thing over and over again. And I usually do this with a partner so that way it's not all one-sided, and so they get that collaborative piece of assisting another student if they need to and just talking about it in general. And that's how I end my rotation. We do our 1-question assessment, having them do the rotation, write the pre-image and image coordinates, and describe what's happening. So whether they use the algebraic rule or just a written description of what's happening to the coordinates. And then we move on. So the way our curriculum works is dilations is a separate chapter because it deals with non-congruent items, I think. I don't know, my brain's farting. But we don't do dilations in the same unit that we do translations, reflections, and rotations. So I won't be covering them here. So I'm sorry if you made it all the way to the end of the episode hoping that I was going to cover dilations and now I'm telling you I'm not. So I'm sorry if that's you. But that is how I scaffold transformations for my students. So in 30 minutes is what we did in the course of 5 or 6 weeks, maybe a little longer. So to quickly summarize, for the scaffolds that I use, translations start with a 1.1 quadrant, 1 movement thing and slowly add in more things. And then for reflections, use mirrors, use tracing paper, use movement to understand y-axis versus x-axis reflection, so bow, high five. And then for rotations, practicing that when you turn, you're facing a different direction and creating that triangle with your arms, so that way students, as they make those quarter turn rotations, they see what direction they're facing. And then again, using tracing paper. Do not be like me and wait 4 years of trying to teach transformations and rotations and just being stubborn about using tracing paper. Just do it. Just do it. We're Nike endorsed here. Just kidding, we're not. But just do it is their slogan. Is their slogan? Is their slogan. All right, I think it's time to end this episode. So thank you so much for being here. I appreciate it. If you want some scaffolded resources for your transformation unit, I have an entire unit that covers reflections, rotations, and translations, and it has a bunch of different activities as well as some scaffolded worksheets for students to work through. So you can find the link to that transformation bundle in the show notes on my blog. And as always, if you have any follow-up questions based on today's episode, head on over to Instagram and send me a direct message. I'm happy to talk through anything with you. And with that, I'll calculate later. Thank you so much for tuning into today's episode. To find all the links and resources to things talked about in this episode, head on over to MissKuipersClassroom.com and click on podcast.